Hi, I'm Yuki.
Hi, I'm Hilman.
Fadil. Shahid.
Alex.
Women. Yeah, group 2.
Hi, we are Group 2. The topic we will be doing today will be the factors affecting the capacitor. We will be presenting a skit to explain the factors affecting the capacitor. But first, let me do a brief introduction about the capacitor and the factors affecting it. A capacitor is an electrical device used to store the electric charges. Capacitor is expressed as the ratio of the electric charges Q on each conductor to the potential difference V between them, which rounds up C equals Q over V. The three main factors that affects the capacitor is the plate area, the plate spacing, and the dielectric material, as well as the positioning of the capacitance. Now, let's move on to the construction of the capacitor.
The making of the capacitor. The construction is such as dielectric insulating material is sandwiched in between two conducting materials. The plastic cup, polyethylene, has a dielectric constant of 2.26, while our conducting material will be aluminium. This is the end product with two cups stick with two aluminum foil and a normal cup as casing. The casing is to prevent my hand from adding extra dielectric constant and also protecting the aluminum foil from affecting the capacitance value.
Hey Fadil.
Hello Lex.
Can you explain to me the factors affecting capacitance?
Yeah, sure, it's easy. Come, let me show you with the help of my video. Ching! Firstly, you put the foil together. When the foil opposing, there's no overlapping of foil, zero capacitance. But when they overlap each other, the capacitance value increase by the area. As you can see, as the foil overlap each other, more area means higher capacitance. But as the foil area decrease, the value of the capacitance get lower.
Thanks Fadil. So, plastic is the dielectric for this capacitor. Is there any other dielectric material?
Paper. Look at my video.
Different types of materials have different dielectric constant. Higher dielectric constant result in a higher capacitance. Vice versa for the lower dielectric.
I see. Thanks Roman. So Shahid, is there any other factors affecting capacitance?
Yes, another factor that will affect capacitance is the distance. And I will show you in my video. This is how I vary the distance for the electrodes. As you can see, as I increase the distance, the capacitance will decrease according to the formula where the capacitance is inversely proportional to the square distance of the electrodes.
I see. Thanks Shahid.
You're most welcome, Alex.
That should sum up all the factors affecting capacitance, isn't it?
Yes, I think so.
There's still one more. Alright, let me explain to all of you. If connected in series, the capacitance or capacitor decreases. According to the formula shown as an example here, total capacitance is equal to 1 over 1 over C1 plus 1 over C2 plus 1 over C3. Moving on to the capacitor connected in parallel. Capacitance increases when capacitors are connected into parallel. As you can see, the formula written here for this example, total capacitance equals to C1 plus C2 plus C3. The value of the total capacitance is higher when connected in parallel than in series, even though both circuits consist of the same number of capacitors.
After understanding the factors affecting the capacitance value, do you know what capacitor is mainly used for? There are different types of capacitors such as a ceramic, mica, paper, electrolytic, and variable capacitor. Different capacitors serve different purpose. For example, a mica is being used in high-frequency tuned circuit and used in applications such as a filter and an oscillator, while electrolytic is being used everywhere except for the military application due to its low cost and high capacitance value. An example of a paper capacitor will be the oil-craft paper capacitor. It is being used in high voltage application. We have come to the end of the video. We hope you enjoy it. Thank you.